Every time.
Okay, guys, so I'm in a group meeting up here because the internet's not working downstairs, so just so you know. You're doing a what? I'm in a group meeting because it's not working downstairs. Okay? Do you want to go like somewhere quiet, like the boys' room?
I think this will be okay.
How quiet do we need to be? You don't need to be quiet. Literally, just like be in the
Okay.
You have
Can you guys hear me?
Yeah.
Yeah.
Can you guys hear me?
Yeah. Yeah, we can.
You can? Okay. I can't hear you very well.
How many siblings do you have, Marin?
It feels like 50. I have 4.
Okay.
Yeah.
You're the oldest?
Mm-hmm.
Nice. Well, that's fun. I bet they love having you there.
Yeah, it's actually really fun, but they all just came home at the same time, so it was just super loud for a second.
Gotcha.
That's funny. Okay, well then I think I understand up through 8, and then 9, it's just the medium. The P is the mean, right?
Right.
And then for standard deviation, did you work out by hand that whole long formula, or is there a different way to do it? Work out by hand the whole long formula.
Formula. Yeah.
Okay. So
Yeah, I just did it on Excel.
Yeah.
what is the Z-score you would use for that?
The Z-score.
Yeah, were you able to figure out those?
Yeah. Yeah, the Z-score formula looks like a giant mess, but that's just because the standard deviation formula is a mess.
So
Yeah,
since we just figured out the standard deviation, we can just plug that in for the next one.
Right.
Yeah.
One thing, I had a problem with rounding with that. That's why I should probably do it in Excel.
Oh.
Yeah, my answers didn't come out the same because I rounded my standard deviation.
Gotcha. Gotcha. Okay. All right, I think I get this. Should I open up the quiz?
Let's do it.
The test took me so long, you guys. It was ridiculous.
Gosh, that test.
I know, I wish I knew what I got wrong on it because I don't know what I did wrong, you know what I mean?
I can almost guarantee I missed the percentile questions. They totally confused me. I'm sure they were so easy, but I couldn't remember how to do them, and I know I missed them. And there was what, 2 of those?
Yeah, I think so.
I don't even remember.
And then the other one that I'm pretty sure I missed was the one where it was like, on all of the quizzes we had to say we are 95% confident that the true mean falls between blank and blank.
Oh, yeah.
But then on the exam, they gave us that phrase, and then they wanted us to say what that meant. And then I got all confused. They all looked right to me. I'm sure I missed those.
I know. I always miss those on the quizzes.
The wording on those, it just trips you up. I'm sure I missed the percentile ones and those, and then maybe one other thing. So what are you going to do? I could have studied all week long and still missed those same questions,
Mm-hmm.
So what do you do?
I just realized I have, and I'm assuming it's just because I've gotten 100% on most of the quizzes, but because I got a B on both of the tests, I have a B in the class, which is super disappointing.
I have a B in the class too, and I got an A on the first test. But
So what would you have to do to get an A? Get 100%?
I don't usually, I'm a complete slacker, and I've been getting B's or C's on the quizzes, and half the time I don't retake them. Out of pure laziness, I'm sick of doing homework, I'm not going to retake it. So I think quiz grades are bringing me down. Because I got a 95 on the first exam and then an 85 on the second exam, and I have like an 88 average.
So weird. Yeah, because I've done good on the test, but not as good as you on the. I mean, I've done good on the quizzes, but I haven't either of the tests.
Yeah,
I guess
the
that's
quizzes
my
must be worth more than we think they are. I should probably start trying a little harder on them. Like last week on the quiz, I didn't even realize we had to take one. I had just taken the exam. I couldn't have cared less. I got a 70% on the quiz and I just turned it in and I didn't even try to retake it. I was like, I don't care. I'm sick of doing schoolwork. I'm done. You know, but it's that attitude that's like bringing me down.
Yeah,
All right.
it's hard.
this is why exams are 60% of our grade.
Oh, whoa, wow, that's a lot.
Yeah.
Did you get a B
Yeah.
on the first exam, Josh?
What did I get? I think I got an A on it.
Yeah, I think you
Yeah,
did
I
well.
remember you got like a 97 or something.
Oh,
I think
oh,
that's
so
what
then
I.
your
Yeah.
70
You like missed one. I
matters.
was like so jealous.
Well, I got a 79 on this last one, so.
It was
So it evens
probably
out.
those stupid questions that the wording was so messed up on them.
It was a mess. Yeah, I hated those.
I literally took the exam twice. Like I reworked every single problem.
That's what I should have done.
But those ones, I mean, like you either know what the answer is or you don't. Like I could change my guess. You know, it's not like you're doing math work, it's wording, and I couldn't remember the way they wanted us to say it. I think I chose there's a 95% chance that the true mean is in whatever and whatever, and I don't think that's the right answer.
Oh yeah, those ones were hard.
Yeah.
Yeah, I don't think that's right either.
I'm kind of full quiz. It's about.
Are we ready? Number 3.
Ready?
I think it's C, but I'm not sure. What do you guys think?
And the area of each slice represents the proportion of the total occupied by the category. Yeah.
Yep. And number 4 is C. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest going from left to right.
Yeah.
Yes, that's true.
Okay, these are going to be harder. We conclude that proportion P is normally distributed if NP is greater than 10 and N, parentheses 1 minus P, is greater than or equal to 10. Is P the true proportion or the sample proportion?
Sample?
Yeah.
I think it's sample.
I don't remember reading anything like that.
I'm trying to remember.
Number 3 in the homework. So sample distribute samples. There was P equals population proportion. Oh, maybe it's true proportion. Because the population would be the true thing, right?
Yes, yep. I think you're right.
Yeah, let's go with that one. That sounds right. So true.
And then N, sample size, same.
Yep, sample size. Right?
Yeah.
Oh. If P equals 1/4, what's the smallest sample size that satisfies the requirement?
Oh, I don't know.
So we do 5.
I don't even know what formula we would use here to figure this out.
If P equals 1/4.
Can we talk about it after? I didn't say anything. Here's my phone. You can look. Can you just
Boy.
wait?
Let's skip that one and come back to it.
Okay.
Yeah.
What
Use
is
the
the
following
mean of P? So that's like number 9 on the homework. That's like 9A on the homework.
Okay.
So is the mean just 0.4?
I think it's just 0.4. Are they trying to trick us?
No, I think that's right because we just got it in a percent in the homework.
What's the standard deviation of P?
So 0.4 is equal to the square root of 0.41 minus 0.4 over n, right? I lost my calculator right after I took the exam, and I've been using like my phone calculator. I need to just use Excel, huh?
Hey guys, I have to go. I'm sorry.
Okay. It's okay. Do you want us to email you the answers or?
It's okay. I'm sorry. I just have to go right now.
Okay, talk to you later.
Okay.
I'm working on this.
Mom,
Yeah.
can you right here, down here, gray, rainbow, in the hall, gray, rainbow in the hall. No, grace, in the hall.
Grace. Rainbow.
Mendel.
Mendel.
What is this for? What is that for?
There you go. I'm doing something wrong, Josh, because I plugged this all in and I really have nothing that I'm trying to find out. What am I trying to find out here?
Just the standard deviation.
Isn't the proportion 0.4?
Yeah. Mm-hmm.
So I have 0.4 is equal to the square root of 0.4 parentheses 1 minus 0.4 over 24. Do you see what I mean? Like, what am I doing wrong? Because then I'm not really solving for anything.
I see. I made a let's see.
What am I doing wrong?
They have the book up.
Yeah, I printed out the book.
Okay, let me find. Okay, so if you go to 3.1. And it's under the section that says answer the following questions.
Yeah.
Like number 6, it shows you that standard deviation of P equals, and then that it gives you the standard deviation formula.
Yeah.
It's not P equals that formula. It's the standard deviation of P equals that formula.
Oh, so that's my variable that I'm trying to find.
Right. So
Gotcha.
No, P right there is not part of the formula at all. It's just saying the standard deviation of P is this formula.
Gotcha. That makes sense.
Yeah, I wrote it in my homework that way, and I looked at the answer key, and I'm like, oh, okay.
That doesn't make sense.
Yeah.
I'm just getting 0.1. Is that what you're getting?
That's what I got.
Okay. All right. Let's assume we're doing that right.
You know,
Brittany's batting average is 0.300. We want to determine the probability she will get more than 35 hits in her next 100 at bats. So N is 100 and P is 0.3. What is proportion of P? This is just like what we had above. Do we just put 0.3?
let me read this again. Let me read the book and see.
I know, I have a feeling we're doing those wrong.
You know, where is it?
Yeah, I'll look too. Well, in 3.2.2, it says the mean of the proportion of P is P. So the mean of P there, which is, wait, no, that's mean though. Never mind.
The true proportion of the random variable is P squiggly thing. Okay, wait.
Oh, it should be proportion of P is equal to X over N.
Okay, so X is, would X be 35 hits and N be 100 at bats?
That's what I'm thinking, but I am not positive.
And that's what would make sense.
So we would put there 0.35.
Yeah.
Let's try it.
I think that's what we need to do for
Number 8.
8. But it doesn't give us any other information though.
No, it doesn't. Oh, this is so confusing. So we'll keep that one how it is.
Yeah.
We still don't know how to do number 7. This is one of the harder quizzes we've taken.
I know.
What is the standard deviation of proportion of P? So well, that's this formula here.
So it would be
So if we have number 10 wrong, we're going to get number 11 wrong. That sucks.
yeah. Divided by.
Oh, I hear your son.
Do you?
Yep. Let's see. I got 0.0476.
What I got.
Okay.
All
right.
0.048. Oh, Z-score. Okay. So this we got to be careful not to round.
So this is where we got to go to the normal probability app, right?
Oh, is that what we have to do?
I think so. I think we plug in. Oh, no, we have to have the Z-score to use the probability app.
Yeah.
No, we got to use the formula, which is the really long, painful one. But we did just figure out the standard deviation, so we know the bottom of it.
We just have to make sure not to round it.
Oh, I see what you're saying. Yeah.
Okay, so we did.
I'm getting 1.0482.
I'm trying to, yeah, I haven't done it yet. I'm trying to figure out how to use this unrounded or the rounded, whatever it is, this calculator
On Excel or on your calculator?
on my calculator.
Oh, gotcha.
I should probably do it on Excel though.
I know, I should probably be using Excel too. But I'm using a very ghetto calculator. I need to find my real calculator.
And then the standard deviation is 0.35 times 1 minus 0.35. This divided by that. All right, 1.048. Is that what you got?
Yep, that is what I got.
Awesome. Thanks for waiting.
Oh, no worries. I'm not in a hurry. What is
All right,
the
so what is-
probability Brittany gets at least 35 hits in her next 100 at bat? I thought we already knew that.
So now that's where we use the applet.
Oh, this is confusing. All this wording.
I know.
Gonna kill me. So we just put in the z-score 1.048. Ooh, what do we have highlighted?
What is the probability Brittany gets at least 35 hits in her next 100 at bat? So 35 hits or more. So it's going to be the
Greater than?
yeah, it'll be the
Like
upper
the
end.
right? Yeah. So what, 0.1473?
Yep.
So 0.147.
Thanks. That means if we got 10 wrong, we get
Yeah, we might press submit on this and get a 20%.
yeah.
It happens to me all the time.
Dang it. I hate it when questions rely on each other like this.
Oh, too funny. Well, one of us will submit at a time and we'll figure it out.
Yeah.
And then we can always retake it too. So
Yeah. Mm-hmm.
if I can make myself not be lazy. If the true proportion of people who support a political candidate is P is equal to 0.52 and N is equal to 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of P? So 0.52, 1 minus 0.52 over N is 2,000 square root. I got 0.011.
0.011. Yep, that's what I got.
Okay.
Z-score.
Okay, so we'll put that on the bottom.
Oh, dang. We need both P's to figure that out, though.
Do we? Where's my formula? Uh-oh, how do we get that?
That the results of the survey will suggest the candidate is losing. Okay.
Well, isn't the probability of P just P divided by 2,000? Is that right or no? No, we have to have the sample.
We need,
size.
yeah, it's a sample.
Huh.
And if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will, okay. So our P with the little squiggly is going to be 1,000. The reason for that,
Yeah.
the reason for that is because it's asking for what's the probability that the results of the survey would be less than 50%?
Yep, that makes complete sense.
Okay, perfect.
Good job.
So we'll use that. So it would be 0.5 you'd use in the formula stuff.
Gotcha.
Okay.
Do you have a negative?
Yes, I do. I have
Negative.
negative 1.790.
Oh, I have something different. Let me see what I did wrong. Oh, probably because I used my rounded standard deviation. Dang it.
Oh. Mhm.
I can't do that.
What number do you have?
I had negative 1.818. I did 0.5 minus 0.52 divided by 0.011.
Oh, yeah.
It's because is it because of my standard deviation?
Yeah, because
Okay.
the standard deviation is like 0.011171.
Okay.
Yeah.
Okay, so now I'll take that 111713. Okay. 0.5 minus 0.52 divided by 0.0111713 equals. Okay, now I got negative 1.7903. Does that sound right?
Wait, what was that? 1.790? Yeah. Yeah.
Yeah, okay. Whew, okay. You're right. We're gonna have to be careful about not rounding that standard deviation.
Yeah.
Okay, so negative 1.790. What is the probability the survey results will show the candidate is losing even though the true P is 0.52? What? So the probability, it wants us to plug that z-score into the probability applet, right?
Well, the probability of a candidate losing is when they're below 50%. So it's just a funky way of saying what's the probability of this candidate losing. Really weird wording.
So
you still use that z-score that you got and you plug that in.
the negative 1.7903?
Yeah, and you plug that in and highlight the left side.
Okay, that's what I did. And I got 0.0367.
Yep, that's what I got.
Sweet. So 0.037.
Yeah.
Rounded. All right. Oh, wait, we skipped that one question up ahead.
Yeah, let's go back. If P equals 1/4, what is the smallest n that satisfies the requirement?
I have no clue how to do that.
Satisfies the requirement. Would it be 4?
If P is equal to 0.25, oh, I have no clue.
Not sure. Let's say anything in the book.
I'm looking through the book real fast here. I mean, the probability of P is equal to X over N, we don't have enough information to know. Oh, this is probably so easy and we're like way overcomplicating it. You know what I mean?
Yeah. Hmm.
We don't know what the sample mean is. Should we put 4 and see what happens?
Yeah, let's give it a try. I'll go ahead and submit.
If we put 4 and P is the probability, then the probability is equal to 4 over 4, which is 1, and we know that the probability can't be, well, it can't be greater than 1.
Well, N is the bottom part of the equation, though.
So, yeah, I don't know.
I honestly have no idea.
Should we put 4 and see what happens? No, it can't be 4. That's what it is now.
I know. So if we find, let's see.
I'm looking. No. The only thing I can think of is where it's like 3.2.1, and it's talking about how we use the central limit theorem to a sample proportion, and NP is greater than or equal to 10, and NP is greater than or equal to 10, or in parentheses 1 minus P. Ooh, that's what we have to do, right?
I see, yeah.
Is that what we're talking about here? If we put in parentheses 1 minus 0.25.
We can apply the central limit theorem to a sample proportion if both of the following conditions are satisfied. What's NP? N times P?
That's what I'm thinking. I have no clue what I'm doing. I'm doing N parentheses 1 minus 0.25 is equal to 0.25.
Okay, I think you're on the right track there, because it says if P equals 1 over 4, what is the smallest n that satisfies the requirement? In the book, it says that's the requirement. Like, these conditions have to be satisfied in order for us to continue with the problem. So if n times 0.25, n times 0.25 has to be greater than or equal to 10. And n times 1 minus 0.25 has to be greater than or equal to 10 as well. So the smallest number that would get us greater than 10 would be 40. Because if we did 40 times 0.25, then that's 10.
Okay.
So I think it's 40.
Okay, let's try it. That makes more sense than 4.
Yeah, definitely. Okay, I'll go ahead and submit it.
Are you sure? Okay.
Yeah.
I don't mind. We can both retake it, so.
All right, I'll take a look here. Looks like we only missed 2.
Really? I'm shocked. I thought you were going to be like, we got a 20%.
We got number 7 right.
Really?
Yeah, so we got that one right. We just got number 12 and 13 wrong.
Let's see. 12 was the z-score. Really?
Oh, okay.
And then the probability, because obviously we got the z-score wrong. Did we just round it wrong?
Might have.
Let's see.
Let's do it again. Let's see.
We guessed and we put 0.5 in there. Maybe that was wrong.
It might have been.
It makes sense. Oh, this isn't the one that we, no, this isn't the one that we did that. That was the other one. So we were right in putting that. No, we didn't do that with this one.
So that means,
this one we did 0.35 minus 0.3. So maybe our 0.35 was wrong.
Well, number 10 says that it was right, though.
Oh, yeah, good point. Okay. So then, yeah, it must have just been a mathematical error.
Yeah. Let's see what we got here. Let me do this again. Okay, so
you know what? I used 0.35 in mine, and I should have used 0.3 in that formula. Did you make the same error?
Oh, I did. I did, yeah.
Silly error.
0.3. Okay, and then out of 100 hits.
That was a silly error.
Okay, so 1 minus 0.3. Okay, out of 100 hits, I did that divided by that. And took the square root of that. Okay, so I got negative 0.436 as the standard deviation. Or
I got I got something different. What did I do wrong? I've got 0.3 parentheses 1 minus 0.3 divided by 100 and then take the square root of that. Is that right?
Wait a second. I'm really confused now because number 11 is right.
The standard deviation. Oh, we got number 11 right. Oh, this is confusing.
We got number 11 right.
I'm looking at like my old problems and it's just confusing me. So we got 10 right and 11 right.
Yeah, it was just 12 and 13 we got wrong.
Oh, okay, so z-score. Okay. Oh, well, that's confusing because I feel like I'm looking at my formula that I used for the standard deviation and I should have gotten it wrong. Because I used 0.35 and that's not P. That's weird.
Yeah, isn't that weird? Oh, yeah, I don't know. So we got that right, so it is.
Weird. See, this is where I get lazy and I'm like, let's just turn it in.
I know. You know what? Now that is that right? Oh, that's what I got. I got it.
1.0482 z-score. Okay.
0.35 is 0.3. Yeah, I got 1.0482.
1.0482. That's what we got last time.
Yeah.
Weird.
Why is that?
Maybe we should put a negative in front of it.
Oh man, I have no idea. That is so strange. Let me look at this formula again.
What did we do wrong? I feel like we should have gotten the standard deviation wrong.
I know, right?
We used the wrong thing. Right? For standard deviation, we have to use just P, and I used the proportion of P, right? That's confusing.
Yeah, that is really weird. We got the same answer when we used the proportion of P. Or we got the right answer, I mean. What is that? 0.35. Where's the standard?
I just reworked it again and got the same answer. So I don't know what's wrong here. You know what? I think we're confusing our 0.35 and our 0.3s. Let's try getting our z-score, flipping those and doing 0.3 minus 0.35. Since we confused that on our standard deviation and got it right, you know what I'm saying?
Right. Let's see.
So then we get, when we flip those two, we get the same answer, 1.048, but it's a negative. I'll try that.
Okay.
I don't understand why those numbers are not in the places I think they should be, but whatever. And so then we'll plug that into our z-score. Did we highlight the wrong thing?
I don't know. I don't know what we did.
Let's see. Last time we did just the right? And got 0.1473. Is that what we did? Yeah.
Yeah.
So then this time, since our z-score is the negative, would we have the middle and the right?
Yeah.
And the area would be 0.8527, so 0.853. I'll try it.
Yeah, give it a try. See what happens.
Those were the two that we missed.
Those are the only two, yep.
Okay, we'll try that. I don't know if I understand it, but it's at least trying something else. Let's see. Right. Nope, we got 12 and 13 wrong. Weird.
Oh.
I don't know what we're doing wrong. I mean, we obviously understood it because we just did the same exact things on the following problems.
Right.
Weird. I'm not going to lose sleep over it. I'm turning it in and I'm done.
Yeah. Yeah, that sounds good.
Weird. All right. Well, we did decent.
Yeah.
I feel like I understand it better now than I did an hour ago, so that's good. Yeah, so that's good. All right, dude. We'll see you Thursday.
All right, see you Thursday.
Bye.